Welcome to Cybercast. I'm your host, Nikki Henderson. The Defense Department is amid an immense effort to get 5G and future Gs right via its 5G to Next G initiative. But with any new technology, one of the major challenges to get right is security. While the purpose of the program is to ensure that DoD can operate through existing commercial infrastructure in the safest way possible, it's not a simple task. Dr. Dan Massey, director of the Operate Through leg of the initiative, says DoD is focused on the confidentiality, integrity, availability, and observability of messages transmitted through its communication systems. DoD is trying to utilize the millimeter wave to ensure that adversaries can't see their transmissions and to also prevent them from gaining information about operations by observing communication patterns. Dr. Massey joins me in a conversation outlining DoD's 5G goals, its plan to leverage space-related cloud in regard to 5G, and more on the importance of the millimeter wave spectrum to DoD's 5G strategy. Good afternoon, Dr. Massey. It's nice meeting you. And I'm really happy that you took some time out to speak with me today about DoD's 5G initiative. I know we have a lot to talk about, but before we jump into our discussion, would you mind introducing yourself and giving just a brief description of your role at DoD?
Hey, great to be here. I'm Dr. Dan Massey. I'm the director of the Operate Through portion of the OUSDRE 5G initiative. And I come from a background of a mix of cybersecurity and networking. My role in the Operate Through program is to manage the overall portfolio. It's 1/3 of the overall 5G initiative, and we're really excited to be here.
Okay, perfect. Well, we'll go ahead and get started. What is the Operate Through 5G to Next G initiative? What are some of the goals? And can you also tell me about some of the challenges that you're facing?
Absolutely, great question. So let me start off with just a sort of big picture, and then we'll dive into Operate Through. So Operate Through is part of the 5G initiative under Principal Director Amanda Toman. And so what we're trying to do as a large picture for this initiative is ensure that DoD can operate securely and efficiently on the emerging 5G networks. That consists of 3 big pieces. Operate Through is one of those pieces. So one piece is ensuring that DoD can accelerate the deployment of 5G. We have about 16 bases around the country where we're using 5G to do everything from smart warehouses to telemedicine to exploring spectrum sharing. And so that's the accelerate portion of the portfolio. We recognize that 5G is not the end. There will be 6G, 7G, and beyond. And so we have an innovate piece that sits that looks to the future. And I run Operate Through, which sits somewhere in the middle, saying, can DoD operate securely on 5G networks anywhere in the world where we might need to be? And let me say a little bit about what it means to operate through, and then I'll tell you some of our key challenges. So for our DoD and military audience, the concept of Operate Through is something we do every day in every other infrastructure. So, for example, if you look at roads and bridges and rail systems, transportation infrastructure, DoD never begins an operation by saying, first, we have to build our own unique, our own bespoke road and rail system and our own bridge system. Instead, what we try to do is we try to operate through the existing roads, the existing bridges, the existing rail lines when they make sense, right? So in transportation, we operate through. Now, it's important to note that the Army Corps of Engineers can build a bridge across a river anywhere in the world. We will always have that capability. When needed, we don't rely on the right bridges and roads and rail systems being in place in whatever area we're operating in. We always have the ability to build our own, but we make use of what's there when we can. We operate through the indigenous infrastructure when we can. Same thing for host country power, right? If we're operating somewhere outside of the US, we can and do bring our own power, but we also try to leverage host country electricity, power grid, that sort of stuff when we can. Same thing for water, and so forth and so forth. So operate through says, what about comms? Could we operate through existing comms? And this is particularly important with 5G, as worldwide, there are literally trillions of dollars being poured into establishing 5G infrastructure around the world. Can we securely operate on that infrastructure? Just like with the roads and the bridges, we will always have the ability to bring our own 5G infrastructure, to bring our own comms infrastructure with us. And that will always be part of what it means to operate through. But we would also like to leverage the existing commercial infrastructure when it makes sense and when we can do so securely. Just like we'd like to leverage that existing bridge rather than building our own bridge across a river. So that's the general concept of operate through. And so you also asked about the challenges. So Nikki, let me say a little bit about what some of the main challenges in operate through are. And it really boils down to security. So there's great infrastructure being developed out there. We would like to leverage that infrastructure, whether that's buying commercial off-the-shelf equipment, whether that's leveraging existing standards, whether that's actually operating on, name your favorite 5G network provider somewhere in the world. We'd like to be able to do that, but the challenge is, can we do so securely? So really all of our central challenges are around making sure that that's secure, resilient, and so forth. Thanks.
Okay, thank you, Dr. Massey. That was a great explanation of operate through, and thank you for discussing some of those challenges that you guys are facing, especially with security being your main one. So how will DOD leverage space-related cloud, especially in regard to 5G?
Great question. So cloud and 5G, especially space-based cloud, right? So I'm going to start that by, let's say, what do we mean by 5G? And my 5G experts listening know this backwards and forwards, but for some of us, it's important to understand that 5G includes cloud, right? So 5G really has three parts. 5G has the radio access network, which talks about the actual wireless comms. That's clearly a key part of 5G. 5G has the core network. What happens after you get to the cell tower? How do we manage the back end of the network? How do we do network virtualization, all that sort of stuff? And it has 5G MEC, or edge computing. Can we push computing all the way to the edge? Can we leverage that cloud? Can I have that cloud not just back in the Amazon data center, but also have that cloud right there at the cell tower? So that's the 5G MEC. Back to the cloud, right? So we're talking about the cloud, and in particular how space-based cloud integrates in there. So what we have is the desire to bring that edge computing as close as we can to the 5G network. There are aspects of the 5G network that are going to heavily rely on that computing, and the 5G network should integrate seamlessly into our space-based systems. And it'd be great to have some of that backhaul. So some of the processing I need to do is happening perhaps right at the edge on the tower, is perhaps happening just a small amount further back, further back at the space-based system, up on the satellite with processing there. And if we really need it, is happening all the way back on terrestrial large-scale data centers. But we want to push that processing up into the cloud as much as we can. And I'd love to have that cloud up on the satellites. I'd love to have that cloud out on the cell towers. And if I can do that, I can build a lot more powerful communication systems. I can give you a couple examples, just hypothetical examples of aspects we could do with that added cloud compute. Right? So I'd like to do, just sensing for security to detect, vehicles, people, drones, whatever might be around a critical facility. So I can certainly have sensors that have the capability to do that. Be great if I have even lower cost, lower resource sensors that can provide the data and send it back for processing. If I have to send that all the way back to continental United States, if I'm operating, in some remote part of the world, that can have a long latency, and it will diminish my ability to rapidly assess my situation. If I could push that compute all the way to the very edge, all the way out to the system, then I have much more powerful ability to understand my operating environment. I often will have a backhaul system that's taking my local 5G network, connecting, say, my sensors and my other devices, and is backhauling that up via some non-terrestrial link to the satellite systems. If I could have the processing right there, rather than have to go up to the satellite, bounce over to the US, process, come back. If I could put that on the satellite system, that again becomes much, much faster. I can do much more processing. I can make my end systems, much cheaper, simpler, and require less resources, allowing them to operate longer and so forth. So if I can get that cloud computing to the edge into the space system, I can do quite a bit. And I'll just end there with a few other just intriguing examples. I could do this for improved augmented reality, virtual reality for training. We could imagine some telemedicine examples. We could imagine things like even maintenance of whether it's planes, vehicles, whatever it might be, to be able to have all that computing power right there in the edge, or right there at the boundary on the satellite systems, on, say, a small sat system or something else like that. That could be very powerful and enable us to have a lot more capabilities, a lot faster capabilities, a lot more high bandwidth capabilities than we might have had before. So that's kind of our view of where we would intersect with cloud and space-based cloud in particular.
Okay. Thank you so much, Dr. Massey. So I guess this leads perfectly into my next question. So how will cloud compute and connectivity converge with satellite-based solutions?
So I think what we're really looking for in that convergence is, if the network does this right, it should not really be aware or matter to the end devices where that compute power is. Right? Whether that compute power is at that 5G MEC, at the satellite, up on the small sat, up on the satellite, back in a data center, somewhere in the continental US or wherever it might be. We'd like to get to the point where it's seamless, and those should converge to the sense of, when you use the internet right now, you don't really know or care where the routers, where the switches, for the most part, the network operators obviously do, but the end user, as we talk about this over the network, I don't really know or care where the routers are connecting me to you, where the fiber, where the fiber or satellite link or 5G links, whatever they might be connecting us are. That's something that matters a lot to the network operator, but doesn't matter to you or I as we hold this conversation. We want to see the convergence of that cloud, that again, it doesn't matter whether that cloud is the 5G MEC right at the edge, or the space-based cloud, or the typical CONUS, CONUS data center-based cloud. That should be as unimportant to the end user as the fact that where our routers are physically located are important now. So we're really hoping to see that convergence. Now, one thing where that's going to matter, where it will matter a little bit differently, is latency and bandwidth are always key aspects for any kind of computation, any kind of cloud-based resource usage. So if I have an ability to get higher bandwidth availability to the cloud, if I have ability to get lower latency to the cloud, those can be really powerful. So in that sense, I do care where the cloud's located, whether it's at the tower, on the satellite, back in the data center. But it's that should happen sort of at the network layer, at the operator layer. And so that's sort of where we see the convergence of the cloud, and it shouldn't really matter whether it's in space, in a data center, or at the MEC, at the cell tower.
What are some of the considerations that DoD has for cloud space capabilities from SATCOM?
So one of the things that we're particularly interested in is is this for space connectivity and space cloud for backhaul in particular. So we're back in that environment where we got a pretty good 5G deployed network, and now we're looking for a backhaul solution. So that backhaul solution can be, can and often will be a satellite-based, non-terrestrial-based solution. That's a great way to kind of get our connectivity back up to the larger system. It's also a great way to connect our network with more computational resources, some of which we can bring along with us, but others of which we can pre-deploy. So, or really pre-deploy in a space-based scenario, or in a terrestrial-based scenario in a remote location. But the fewer hops I have to do to get to that cloud resource, the more important that cloud resource becomes.
Okay, well, Dr. Massey, can you please discuss the importance of the millimeter wave spectrum to DoD's 5G strategy, and what are some of the security risks and vulnerabilities associated with this spectrum band?
Okay. So let me start from the security standpoint, right? And as we talked about a little bit in the beginning, that security piece is critical across the entire 5G communication system. So we know how to make this work, right? We know whether it's millimeter band, whether it's non-terrestrial, whatever it might be. Industry has come a pretty long way in terms of ensuring that this stuff will function and is relatively easy to deploy, and is increasingly becoming low cost. The challenge here is, can we do it securely? And I've got 3 security problems, and I'm going to add a 4th one on there that we always care about. Right? So our cybersecurity folks will know this, right? In terms of security, I always care about confidentiality, integrity, availability. So confidentiality: if I transmit a message, who's able to observe the contents of that message? Are you able to tell that I'm talking to Lieutenant Commander Gorman, or that I'm talking to you, Nikki Henderson? Can I observe the content of that message? We can do a pretty good job of that in the end systems by encrypting the messages. I'll come back to obscuring that in a minute. The integrity of the message is also very important. Is the message being modified in flight, in transit? Is somebody sending a message that appears to be coming from me but isn't really? Is somebody modifying the contents of my message? So I want that message integrity, I want that message confidentiality. Of course, I want the availability of the system. These are our classic cybersecurity pieces. We're going to add into that observability. So CIA, confidentiality, integrity, availability. But in the 5G initiative, we're very interested in CIAO, confidentiality, integrity, observability. So here's the idea. I want to make sure that you can't infer a whole lot about my operations by observing my communication patterns. Let's say I can encrypt the message, so whatever message I'm sending, you can't see the content. But just being able to know that, I'm talking with Nikki, just to be able to know that I'm communicating this amount of information with Lieutenant Commander Gorman. Those kind of things could give away something about our tactical operations. Could give away something about the pace of our operations, our operational tempo, all those sort of things. So we'd like to be able to operate not only so that you can't see the message, but so that you can't spot the volume of communication. You can't gain information about how we're operating just by looking at, who's talking to who's sending how much message to other folks. So that's a very long-winded way of finally getting to what Nikki actually asked me about, which is, okay, so how does this then tie into millimeter wave and other types of RF communication I can do at the 5G level? So one thing we are very interested in doing is, can we narrow essentially the RF emissions that we're sending out? And can we make those RF emissions blend in to normal operations in a way. This is where some of these newer techniques that 5G brings in terms of the RF spectrum, the 5G RAN, are something we really want to exploit and we really want to make use of. You know, in a simplistic network, I transmit, and you can think of it as I'm transmitting sort of in a broad circle. Everybody within that circle can hear me. They may not be able to understand my message, perhaps because I've encrypted it, but they know that I'm transmitting. And if I transmit in a sort of telltale way, that might indicate, that looks like that could be a DOD asset, or that could be Dr. Massey, or that could be that could be Nikki, that could be whoever it might be. Right? So what we can do with 5G is we can explore some of the other waveforms, we can explore some of the other 5G new radio aspects, some of the millimeter wave kind of pieces to narrow the range as to who can observe the message. If I can change that, ideally, if I could change this from transmitting across a wide radius, across a wide circle, to transmitting across a narrow beam, it becomes harder to observe. It potentially becomes more resistant to types of electronic warfare. Noting we're at an unclassified level here, we'll just say that we're very interested in seeing how we can use new ways of transmitting at the RF level to make sure that our 5G network remains highly available, hard to disrupt, and remains hard to easily observe, to easily infer things about my operational template. So now that's Nikki, that's sort of a long-winded answer to where do these other things like millimeter wave fit in, but I hope that gives a sense of why we care about those and what 5G has some new power and capability to do.
Yes, it does. I appreciate it, Dr. Massey. You talking about providing some information earlier about the security aspect of this and the confidentiality, integrity, availability of the message. I mean, those are all very important things. So thank you for explaining that and talking more about that. I wanted to ask you, what role does AI and machine learning play in helping improve efficiency and reduce interference on the mid-band spectrum DoD will be sharing with industry?
Great question. So AI has the potential to play, and machine learning has a potential to play a really important role here, and to really increase both our availability and, in some sense, increase our security. So if we think about this, we're increasingly operating in this world where spectrum is shared. There's a great amount of competition for spectrum space wherever we are in the world, whether that's the U.S. There's issues about spectrum sharing with CBRS, the citizen broadband radio systems, and with sharing spectrum between military radars and 5G communication systems, and many examples of spectrum sharing. So my colleague, Dr. Roy, has a great way of describing this. He says, we are very good at sharing spectrum on, say, an Excel spreadsheet level. I can come up with a nice Excel spreadsheet outlining, Nikki, you should be on this spectrum band. I should be over here on this band. We should have this band free, and we can all agree on that. And if we start transmitting in the same area, we can have rules for who gets to back off. We can see things like a FirstNet where it's shared between commercial and first responders, and first responders get a priority when needed. And in the PowerPoint, in the Excel spreadsheet version, looks beautiful. The problem is the real world doesn't operate in the Excel spreadsheet in the PowerPoint world. The real world operates where we're going to have to adapt rapidly. We're going to have better sensing of what our environment looks like. We're going to have to recognize, and our electronic warfare folks already know this, this is their bread and butter, that although we might say, you are supposed to transmit in this area, you're supposed to behave in this way, you're supposed to react this way if there's contention, that may not happen. That may not happen because of simply malfunctions, errors, specifications are never perfect. It may not happen because of intentional malicious intent. I'm going to try to I'm going to try to block things. And so on the one hand, we can have a very smart operator scanning all this, understanding what's going on, trying to adapt in real time, and we'll always continue to have that. But the more I can push this into a machine learning environment, the more I can push this into an AI environment, an automated environment, if I can have a better sense of what my operating environment looks like, how that operating environment might be changing, and how I might adapt to it, that can make my comms potentially much more highly available, much more resistant to much more resistant to jamming, perhaps much more resistant to observability if I understand what the environment looks like. So we see a pretty important role for AI and machine learning in helping us understand and visualize what that environment looks like. In fact, at the time we're recording this in late June of 2022, we have two opportunities on the street for industry via the NSTXL consortium to look at how can we adapt and better sense from the device what our environment looks like, so that I could take my phone, my other kind of device, my vehicle, and it could better understand what the RF environment, as well as the core environment and the back to the cloud environment are. I could better understand it from my end system, but that's not going to be me. That's not going to be me walking around, me saying, that's interesting. There's something strange happening in this part of the spectrum. I need to automate that as much as possible. I need to bring in the AI, the machine learning to better understand that. So I want to do that from the device. Equally important, the second of the two industry opportunities that are out there right now is not looking from the device end, but looking from the network operator end. Imagine that you're contracted to operate a network for the Department of Defense, or for any critical infrastructure, or even for Joe or Alice's pizza shop. Right? We would like to understand what that environment looks like in terms of users joining and leaving our network, in terms of RF transmissions that are occurring that may or may not interfere with us, in terms of spectrum sharing, spectrum agility. 5G has really cool spectrum agility potential. We'd like to exploit that. And so we'd like to do this at the speed of electronic communication, at the speed of the computer, not, as my colleague Dr. Roy would point out, not at the speed of the Excel spreadsheet. So Dr. Roy and myself, as well as my colleagues, we're all looking at how can we make that spectrum agility faster, more efficient, more automated. And certainly machine learning AI could play an important role in that. And my personal opinion is it has to, because I'm simply not going to be able to sit there as a human operator, as somebody actually trying to talk on their cell phone, and also try to understand what my operating environment looks like in terms of all the potential with RF, with MEC, with virtualization in the core, and so forth. So AI machine learning, very important, and hopefully will get us in there. Let me add one last thing on that, which is I think that AI and machine learning will play an important role in terms of security as well. I'm going to be operating in a lot of environments, including untrusted environments, including some cases where the underlying hardware may be untrusted or even adversarial. If I could have machine learning and AI come in and help me understand what my potential security risks are, how they're changing, how they're evolving, and even better, provide me some actionable guidance as to how I might adapt to those security risks. If I could do that with AI and machine learning, I think I'd get a much more powerful communication system rather than have some poor operator sitting there trying to figure out, am I being jammed? How do I adapt? How do I, what does my environment look like? So we're looking to use AI for spectrum agility, AI and machine learning for spectrum agility, for security, and for all those sorts of purposes. Thanks.
Oh, wow. Of course, Dr. Massey, knowing what is in your environment is especially crucial. And I would like to hear more in the future about, the developments with AI and machine learning, and how the process is going, and the progress that's been made down the road with these opportunities that you spoke of. We are running a little tight on time, so I'm just going to get another question in here for you. CISA has discussed some of the risks surrounding open radio access networks and network slicing with GovCIO media and research in the past. So how is DOD approaching these risks and concerns?
Those are two great topics. So let me touch first on the OpenRAN and then the slicing, right? So OpenRAN is something we're collaborating with DHS and with other groups. In fact, we have an OpenRAN challenge coming out via NTIA that I believe is out right now or about to come out. So just real quick, the idea of OpenRAN is I like to make the analogy of it's your Apple laptop versus it's your Linux laptop. Okay. So right now, for your radio access network, you can buy some really nice radio access network. I'm going to call them sort of monolithic pieces of equipment from a number of good vendors, and from some vendors we'd prefer that that we think are somewhat untrusted. But you get to purchase that just like you get to purchase your Apple laptop. The advantage there is you get a complete system that's fully assembled, ready to go. Turn it on. There's a lot of complexity in there, and the vendor has solved that for you. OpenRAN takes a different approach. It's more like buying that Linux laptop. So you get to pick the components that go in there. You get to figure out how the components interact. Now, the bad thing is that means you get to pick the components. You got to figure out how they interact. We've got to be very good about understanding the interfaces between the different aspects, between the different components. Otherwise, it won't be possible to build. So, but if we can enable that, it gives us the power to bring in new types of components, new suppliers that might not have otherwise been able to get into this market, to add new security features that otherwise might not be able to, that might not have been possible. And it's not that one is better than the other. Just like, in fact, if you can see video here, sitting on my desk, I have a nice, I've got multiple operating systems. I'm talking to you from a nice Windows government operating system. Nearby, I've got an Apple laptop, which is great, and I've got a Linux laptop that I can configure myself. It's just different flavors, and different flavors work differently in different areas. So OpenRAN is something that we're very interested in. We think there's a lot of potential for building more customized and potentially higher security level 5G RAN, the radio access network systems. So that's the OpenRAN. I know that you're short on time, so apologies for that. Let me also jump over to secure slicing just real quick. All right, so slicing, it goes back to sort of the 5G core, a little bit of the 5G RAN and MAC, but mainly at the core, and says, I can take the network operated by your favorite network operator, company ABC, and I can impose essentially a virtual network, a slice on top of that network. So I could do that in order to give me a better performance guarantee. And this is fairly well understood in terms of slicing. I could ask for a network slice that gives me lower latency, or I could ask for a network slice that gives me greater bandwidth. So I'm operating on top of company ABC's network, but on top of that network, I'm getting my own slice for higher bandwidth than the usual customer would get, or lower latency. One very interesting thing we're looking at with DOD, with the DOD and DHS and others, NIST and other folks are looking at as well, is do we have the concept of a slice that adds security? Not just better bandwidth or better latency, but can I have a secure network slice? Does that make sense? Is that something we should get? And I'll leave with an interesting question there that certainly within Operate Through and DOD and DHS as a whole are looking at. I understand a network slice that gives me low latency. I can measure that. I can see when I'm getting it. I can see when I'm not. I understand a network slice that gives me high bandwidth. I can measure that. I can see when I'm getting it. I can see when I'm not. Can I have a network slice that gets me better security? How do I measure that? how do I know when I'm getting that? How do I assure it? That I think is an interesting open question and a key question for operate through as a whole. So that's sort of our brief take. Well, not so brief take on OpenRAN and on secure network slicing.
Okay, great. Thank you so much, Dr. Massey. Before we close, I just want to know if you have any final thoughts or comments you'd like to add about our discussion today.
Just a few quick final thoughts. So first, thank you for the opportunity. We're always excited to kind of get people interested in 5G and how we can adapt, especially military use cases to 5G. So thank you for the opportunity. For the industry folks out there, we have current opportunities, for things like OTA, other transaction authority for the government contracting folks. We'd love to see more activity in this area for our DOD users and our critical infrastructure users. In fact, anybody who's really interested in adding more security into 5G, we're excited to continue those engagements, to expand those engagements. There's a number of venues to do that, whether that's through the 3GPP standards organizations, which set what 5G will be next and 6G as well, or whether that's directly engaging with us through some of these opportunities that I've mentioned. We're very excited to continue that work, and lastly, we recognize that this is a case where DoD would very much like to be on track with industry, not fighting against industry. So, key part of Operate Through is, can we align industry and DoD, and so that we can leverage all these cool and all these trillions of dollars in investments in 5G, rather than having to build our own bespoke systems that may or may not interact. So thank you very much, Nikki. Thanks.
Cybercast, along with GovCast and HealthCast, is a production of GovCIO Media and Research. For more podcasts and to check out the other shows, head to govciomedia.com. Watch out for new episodes released every Tuesday and Wednesday across our shows. You can follow all of them in your favorite podcast platform, and if you like what you heard, make sure to let us know by leaving a review. And if you have any topics you think we should look into, contact us at newsletter@gcio.com.